In this next set of examples, instead of being given a graph or just given certain information about the derivative, the second derivative, and the original function, and we need to sketch a possible graph given that information. So here we're told that the derivative is greater than 0, or the derivative is always positive. That means our function should always be increasing. We're told the second derivative is greater than 0. That means our function should always be concave up. And finally, we're told that f of 1 equals negative 2. So one fact about our function is that when x is 1, y is negative 2. So we know it must pass through that point. So we know it's always increasing and always concave up, and it must pass through that point. So it might look something like that. Let's consider the next example. In this example, we have 5 facts. First, the derivative is greater than 0 or positive when x is greater than 1. That means that it should be increasing when x is greater than 1. The derivative is less than 0 or negative when x is less than 1. So when x is less than 1, our function should be decreasing. F prime of 1 equals 0. This means at 1, there should be a horizontal tangent. F double prime of x is positive. This tells us that our graph should always be concave up. And finally, we have a fixed point, f of 1 equals negative 1. So we know all of this information about our original function. So let's sketch a possible graph. I always start with the known points, so f of 1 should be negative 1. I know that it should be horizontal there. It should be increasing after that and decreasing before it, and always be concave up. So, since it should be decreasing before it, but concave up, we might be doing something like this. Here there would be a horizontal tangent, and it should be increasing after it and remain concave up. So our graph might look something like this. Let's consider the next example. In this example, we're given 4 pieces of information. I've rearranged them a little bit. First, we know that the derivative equals 0 when x is less than or equal to 2. So this means our graph should be horizontal when the x values are less than or equal to 2. After x is greater than 2, the derivative is greater than 0 or positive, which means that our function should be increasing after 2. We know the second derivative is greater than 0 or positive after 2, so after 2 our graph should be concave up, and we have a fixed point that f of 2 equals 1. Using this information, if we tried to sketch a graph, it might look something like this. We know that when x is 2, our function's value is 1. It should be horizontal into 2, and after 2 should be increasing and concave up, perhaps looking something like this. Let's consider the next example. In this example, what we know is that the derivative is less than 0 or negative when x is less than negative 1, so our function should be decreasing on that interval. We know the derivative is greater than 0 or positive when x is greater than negative 1, so it should be increasing on that interval. We know that the second derivative is always negative, which means our graph should be concave down on the entire interval, and we've got a point of negative 1, negative 4. So, if we sketch that graph, it might look something like this. We have our fixed point of negative 1, negative 4. We know the graph should be decreasing and concave down into negative 1, and increasing and concave down after negative 1. So here's a possibility for our graph. The next example. For this example, we've got quite a bit of information. I've rearranged it to have a slightly different order. The first fact So I'm keeping the derivative in order from left to right based on the x values. So I know the derivative is greater than 0, or positive, when x is less than -3. So my function should be increasing into -3. At -3, the derivative equals 0, so it should be horizontal there. From -3 to 1, the derivative is less than 0, or negative, so the function should be decreasing. At 1, the derivative is 0, so then it will be horizontal. After 1, the derivative is greater than 0 or positive, so then it should be increasing. Then we know some things about the second derivative. Before 0, the second derivative is less than 0 or negative, so it should be concave down. After 0, the second derivative is positive, so it should be concave up. That also means that that's a point of inflection at 0, because it's changing from concave down to concave up. So, if we were to sketch a graph of this using this information, I know that it should be horizontal at -3, and it should be horizontal at 1. The graph should be increasing into -3, where it goes horizontal. After -3, it will be decreasing, with a potential change in concavity at 0. So it's concave down into 0, where the graph changes to concave up into 1, where it's horizontal, and then it increases after 1. You're looking something like this. Let's look at the last example. In the last example, which I've rearranged a bit, first we're told that the derivative equals -1 when x is less than 2. This means that when x is less than 2, we have a line with a slope of -1. The derivative at 2 does not exist, so we should have a cusp or a corner there. Because after 2, the derivative is positive. So our function should be increasing. Then we know some things about the second derivative. That the second derivative is less than 0 when x is greater than 2. So it's negative, so it's concave down after 2. And we've got a point f of 2 equals 0. So for our final graph on this section, I'll start with the fixed point that when x is 2, y should be 0. Before 2, we need to have a line with a slope of -1. So our graph before 2 should be looking something like this. At 2, there should be a cusp or a corner, because then it's going to be increasing from here and be concave down, so it might look something like this. Again, this takes a lot of practice. You're trying to recognize what the information about the derivative and second derivative tell you about the original function, and then interpret it. And this takes some time and does take some practice.